All right, let's go. All right, let's go. All right. What we're doing today, we want to look at some algebra ideas as it relates to CXC. So basically, we're trying to go through most of the questions that will come in algebra on the exam. So we're trying to just go through to kind of remind everybody what it is that you're required to do, how do you square all the marks that are there and stuff like that. So we're going to start as you go. All right, so here it is. So question one says solve for x, where x is a real number. All right, so when you look on what we have here, I could just write it back. What we have is actually 8 minus x, which is less than or equal to 5x plus 2. So if we want to solve this, what we really want to do is basically you want to isolate your x's, get them by themselves. You could get them on any side you wish. I'm going to gather my x's on the right side. So what that means, I'm going to be adding x to both sides. So when I do that, then negative x plus x give me a 0. I have 8 here. I have less than or equal to, this becomes 6x plus 2. So basically, I added x to both sides, and this is what we have. So lastly, what we're going to do now is we're going to subtract the 2 because I need to isolate the x, so I need to get rid of that 2 on the right side. So I'm going to subtract because it's positive 2, so I'm going to subtract 2. So what I have left now is 6 on the left side, which is less than or equal to 6x. As you can see, 2 minus 2 is gone, and so this is what we have. Finally, we divide both sides by 6. So then we have, if I put it in the clear, 1 is less than or equal to x, or you could have read this from where the x is. You would have said x is greater than or equal to 1. All right, so whichever way you want to represent, it's the same thing here. So this is for 3 marks right here. That's for 3 marks right there. So x is greater than or equal to 1. Now, let's see what they want us to do with it. So here it is. It is said that we want to show the solution, all right, in this section that we just did on the number line. So we want to show the solution on the number line. So remember now that x is greater than or equal to 1. Or you could say 1 is less than or equal to x. So x is greater than it. So how we're going to show this on the number line is that our marker is actually 1. So we're going to go where 1 is. You're going to put a circle here. And because we have the equal, because there are 2 ways. If the equal is in the inequality, you have to shade the circle. You have to shade it. Right? You have to shade it because the equal is in it. And then you want to point towards the numbers that are actually greater than or equal to 1. So you're going to be pointing in that direction like that. You're pointing in that direction. So that would have been it. If you're lifting it off the diagram, you have to put it above it like this. You got to shade it and you point in that direction. So basically, that's what I'm saying. When it is that you're not required to shade, if we had x was just greater than 1, then you do not shade this, right? Because when you shade, you're suggesting that number 1 is a part of the solution. And if it's not shaded, it's not a part. But we got the inequality with greater than or equal, so we had to shade, all right? All right, so let's take a look at the second part of the question. So for the B part of the question, we're looking on how do we expand and simplify. So basically what we're looking at is we're looking at 2x, which is into x plus 5, and then we have negative 3, and then we have x minus 4. What we're going to do is to apply our distributive law, where this 2x that is outside the bracket, you're going to distribute that inside. And the negative 3, you will distribute that inside there as well. So let us simplify this to see what we have. When 2x is multiplied by x, we're going to get 2x raised to the second. When 2x is multiplied by 5, we're going to get 10x. When negative 3 is multiplied by x, you'll get negative 3x. And negative 3 times negative 4, you'll get positive 12. So there it is that we have expanded. Now we need to simplify. When you're simplifying, what you want to do is you want to look on the terms that are like. In this case, we only have these as like terms, right? So that means then the 2x squared will be written back. But 10x minus 3x will give you 7x. And the 12 comes back. There it is. So there it is that we had expanded it, and we also simplified the idea. So the answer is 2x squared plus 7x plus 12. Let us simplify this. So what we have here is 3x squared times 4x to the third over 2x. There are many ways you could approach this, but what I'm going to do is I'm just going to multiply the numerator. So I'm going to put everything over 2x. So at the top, 3 times 4, that's going to give me 12. X to the second times x to the third becomes x raised to the fifth. So that is what I have. So now I'm going to break it down, because for the numbers, definitely I could just simply say, all right, 2 into itself is 1, 2 into 12 is 6. X cancels 1 power of that, leaving 4th. So the final answer is actually 6x raised to the 4th power. Right? All right, so that is what we have for that right there. All right, let's keep going. All right, write as a single fraction in its lowest term. Again, we have two fractions here, and we're adding. If you're adding fractions and the denominators are not the same, then you need an LCM, right? So there are many ways we could approach this. One of the ways that you can approach this, you could do a cross multiplication if you want, right? So basically, with a cross multiplication, this 2 will multiply by that binomial. This 5 will multiply by this binomial. And then the denominator will be 2 times the 5. We can do that. So basically, what we have is 5 times x plus 1 plus 2 times 5 minus x all over 2 times 5. So what we're going to have is 5x plus 5 plus 10 minus 2x all over 10. So just in case you're wondering, we distribute 5 with the x, 5 with the 1, then 2 with the 5, and then 2 with the minus x. So now you want to simplify this because there are some terms that are alike. For example, there is a 5x and a minus 2x. That becomes positive 3x. And then we also have 5 plus 10, and that's going to give us 15. And this is going to be over 10. Now, at this time, remember, this is what we have, right? And they said in its lowest term. This is in its lowest term because there is nothing else that we can cancel down here, right? Even if we should factorize out the 3, we won't be able to cancel 3 with a 10, so this is final. All right, we want to factorize completely. And whenever we see the word completely, it simply means then that when you factorize, you must ensure that uh, you are not finding anything in common in the brackets. So the first level of factorization is always to take out the highest common factor. So in this case, the highest common factor is 4. We are noticing that 4. So you want to factorize out 4. And when you do that, what you're left with is x squared minus 1. Because remember, when you factorize out the highest common factor, so we said 4, you're going to divide the 4 into 4x squared. You're left with the x squared, which is this. You divide the 4 into itself, you're left with 1, which is that. All right? So that's first move. This is not the answer because we do realize that this piece here is what we call the difference of 2 squared. In other words, x squared is a square term and 1 is a square number. So what we want to do is to factorize one more time to make sure that it's done completely. So we're going to have the 4 there. And we're going to open our 2 brackets. Remember, when you're factorizing the difference of 2 squared, it's the square root that you really put inside. So for example, the square root of x squared is x. The square root of 1 is 1. And we're going to repeat the same things. Because it's a difference of 2 squared, we're going to have a plus in one of our brackets and a minus. So there's going to be a plus here and a minus here. And this is what they want to see when they say factorize this completely. If you do not make this effort, then you're going to lose some marks, right? Normally for this type, you'll get 2 marks for it. One is to put the layer here, and the second mark is to put the layer there. Let's take a look again on this here. So as you can see here, we want to factorize this. So this is kind of similar to the one we just did. If you feel like you know how to do this, you could just go ahead and work this out and drop your answer in the chat. So I'm giving you a minute to work out this one. Take a minute, see if you could work this one out. It's very similar to the one we just did. So we have 4x squared minus 16. All right, so let me see what you got. All right, so in this case, again, the moment you're going to factorize, the first thing you want to do is to check, is there any common factor for the terms? The common factor is 4. So I'm going to factorize all 4, which means if I divide this by 4, then I'm going to have x squared, a squared. And if I divide this by 4, I'll get 4 here. So as you can see, we did factorize. But after doing that, this is for 2 marks, we do realize that we can factorize again because there it is that we have the difference of 2 squared. Whenever you have the difference of 2 squared, what you want to do is to open 2 brackets. And remember, you're going to put the square roots inside. So the square root of x squared of a squared is a, and the square root of 4 is 2. And we're going to repeat a, 2. Then you're going to put a plus and a minus, or you could put a minus first and a plus. It doesn't matter. All right. So the bottom line is we were able to factorize. You get 1 mark for that. You get another mark for that. hence the 2 marks right there. All right, let's keep going. All right, so we're looking at 3y to the second power plus 2y minus 8. And we're supposed to factorize this completely. For this one, you can see that there is nothing in common for our terms apart from 1. So we're going to have to approach this using the AC method. So let us list what is our A, what is our B, and what is our C. A is the coefficient of the square, and it's going to be 3. B is going to be the coefficient of the y term, and it's going to be 2. And then C is the constant. It doesn't carry any variable attached to it, so it's negative 8. What you want to do also is be careful not to leave off your signs, right? So C is not 8, it's negative 8. You want to be very careful as we navigate. Now, let's take a look. Remember, though, that this is the AC method. So let us find the AC. AC means that you're going to multiply A times C. The A value is 3, and the C value is negative 8. What this would have left us with is negative 24. Now, what I want 2 factors of negative 24, such that when I multiply them, I will get back negative 24. But when I add them, I'll get the middle term, which is B. So let us list all our factor pairs. All right, I normally just list them in order, ideas. So 24 times 1, 12 times 2, 8 times 3, 4 times 6, or 6 times 4. So these are the only factor pairs of 24 that can work. So we're saying that one of these pairs can give us a 2. When you add and multiply, we get negative 24. So we're going to zoom in on the 6 and the 4. So this is our target. Remember, the 2 things must multiply to give negative 24. It means that 1 is negative and 1 is positive. So then let the bigger number, which is the 6, take any sign of the B term. So B is positive. So the 6 will be positive. That means the 4 will be negative. So we normally do a quick check. In other words, 6 times negative 4 does give us negative 24. 6 plus negative 4 does give us 2. So you could see that we multiply to get our AC and we add to get our B. So we have to take the numbers like this. So let us continue. So we have 3y squared, and then there's the negative 8 here. These 2 numbers that we just came up with, they're going to actually go in the middle. They're going to take the place of this 2. So it doesn't matter which one you write first. Make sure that the variable for the middle term is attached to them. For example, I could put plus 6y. I could put minus 4y. But the intention is that you must put the variable for the middle term on them. Also, it doesn't matter which one you put first, you'll get the same answer. So now that I have 4 terms, what I want to do is that I'm going to have to group them, because we're going to factorize now by grouping. So the aim of the AC method is to get 4 terms so that we could lend ourselves to factorizing by the grouping method. So for the first group, 6, which is 3y squared plus 6y, I'm going to use 3y as my common factor. So 3y into 3y squared will leave me with y, and 3y into positive 6 will leave me with positive 2. Now for my other pair, which is minus 4y minus 8, my common factor is going to be minus 4. If I divide minus 4 into minus 4y, I'm left with positive y. And when I divide this negative 4 into that negative 8, I'm left with positive 2. This is where I normally verify whether or not I'm on the right track. And what do I mean by on the right track? When I do the first factorization, if my brackets are not identical, it means I made a mistake. And when I say identical, I mean a positive y and a positive 2 right now. And it doesn't matter if the positive 2 came first, but the main idea is that the 2 must be positive and the y must be positive. So because I'm seeing that, it means then I'm going to do my last factorization because my common factor is y plus 2. And then the other two things that are on the outside, and they are as follows. This is, so let me just highlight that quickly. We're talking 3y and negative 4. We just have them in the other parentheses right here, like this. And there it is. We have factorized. So, I mean, so this is it. AC method is really to get 4 terms so that you could group them and factorize. All right, so in this case here, we have a simultaneous equation where we're asked to solve the simultaneous equation. So again, this is equation 1, this is equation 2. There are a few ways to approach this, I must say. I'm gonna just approach it one way. So because I'm saying because I'm noticing that I am able to make a direct link between those y's there because one is 1 and one is 2. I realize that if I multiply the equation 1 by 2, I will be able to eliminate y. So my intention is to eliminate the y first, find a value for x, and then I substitute after that. So what I'm going to do is I'm going to multiply. So there are as I said, there are many ways to do this. I am just going to multiply equation 1 by 2. And I'm doing that because I am seeing where I could make a direct link between these two things here, y and negative 2y. I'm able to get my y's to be having the same coefficient, except the sign will be different. So this is what I mean. I'm going to create just equation 3. Take a look. 2 times 2x will give me 4x. 2 times y will give me positive 2y. 2 times 3 will give me 6. Remember, though, that you have to multiply every single thing in the equation. Now, let's take a look at this equation 2 that I had before. It is 5x minus 2y equal 12. That's my equation 2. So if we should add these equations here, if we should add, you're going to notice that when you add, because we have a negative 2y and a positive 2y, when you add, it becomes 0. And that is the intention of eliminating. My intention is to get a 0, right, for one of those variables. So let us add. So the idea, I'm just going to write that we want to add equation 2 and 3. So let's add them. So 4x plus 5x will give me a 9x. And definitely, as I spoke just now, the positive 2y minus the 2y, when you add them, this becomes 0, right? So let's keep going. So on this other side, 6 plus 12 does give me 18. So my intention is to find a value for x. So what I'm going to do, I will be dividing by 9, dividing by 9. So you could see here that x is equal to 9 into 18, that's 2. Right there. So I have a value for x. Now, this value that I have for x, here, I am able to now utilize this in an effort to solve for y. Because when you're solving a simultaneous equation, the intention is to have your two variables having values for them. So let us use equation 1. So in equation 1, I have 2x plus y, which is equal to 3. Remember, though, that x is equal to 2, which means I can substitute 2 where x is. So then 2 times x is 2. Then I'm going to add y, and this is going to equal to 3. So basically what we have now is 4 plus y is equal to 3. I will subtract 4 from both sides. So y is equal to -1. So my solutions are as follows. X is equal to 2. Y is equal to -1. Now, with these as my solutions, what we want to do is you want to make sure that you double check. You want to check these back to make sure that it works. So you want to substitute, all right? We just saw that it worked here. So you want to substitute. Matter of fact, let us substitute it in the two places just to make sure. We just said x is 2 and y is -1. So let's work out this one. I'm verifying here. 2 2 is 4 minus 1. It does give me 3. So it worked here. But whenever you're doing a simultaneous, you want to double check your answer at both places. So we're going to go with 5x minus 2y and see if it gives us 12. Remember, this is a verification process. Remember that x is equal to 2 and y is equal to -1. So 5 times 2 is 10. -2 times -1 is +2, and it does equal to 12, which means that we check this out and it is also correct. So whenever you solve your simultaneous equation, what you want to do is that you want to verify. The verification process will seal the deal. It will tell you that, hey, what I just did is definitely correct, right? So x is equal to 2 and y is equal to -1. Let's keep going. If you're just logging on, I'll say to you, if you're new to the channel, you want to subscribe to the channel because there are a lot of videos there to watch. Also, you want to click like, and you could share for people who you know that are doing CXC. All right. All right, let's keep going. Now, another thing that comes a lot on our paper is this, I think it's variation right here. So we're looking at variation, and it says the table below shows corresponding values of the variables x and y, where y varies directly. And this is very important. It says y varies directly as x. Now, we are required to find a value for x and for t, should say, and a value for u, ultimately. Remember, though, that we were told that y varies directly as x, and this is how we set that up. So we want to set up this formula, and it's going to work for us for every time we're going to solve a problem. It says y varies directly. So there is always what we call a constant of variation. Sometimes they will mention it, sometimes they won't. But whether or not they mention it, you must make up your constant if you're not given. So my constant is k. So it says y is equal to kx. So whenever we're doing a direct variation, the formula looks like that, where one variable is equal to the constant of variation times the other variable. Now, you may ask, how would I know which one to go first? You simply follow the reading of, or the narrative of the question. For example, it says where y varies. Because it says y varies, y equal. That's it. Y varies, y equal. If m varies, m is equal. So y varies. So now that we have that, what we want to do is that we want to find t and u, but you need a value for k. Your constant, you need a value for that. So what we're going to do is to take something that already occurred. For example, when x was 6, y was equal to 3. This is what is going on here. We will be given every time a situation that works. So you're going to have the two variables already, and then you're going to use that to find a value for k. For example, if y is equal to, let me go over there, over some more. If y is, let me put it here, if y is equal to kx, and we're looking at a case where x is equal to 6 and y is equal to 3, I can substitute and then find k. For example, y is 3, which is equal to k times x, but x is 6. So if I want to find k, I divide both sides by 6. I'll get 1/2 is equal to k. So I now have my k value to be 1/2. Let me highlight it for us. So there it is. That's my k value. K is actually 1/2. Now, having known k, now this is how they set the things. So I'm gonna find t. So if I'm gonna find t, I'm focusing on this. So t is what I want to find, right? I'm going to change the marker here. I want to find t. So t T is actually an X value that we don't know yet, right? But definitely underneath the T, you're having a Y value for it, which is 9. So you read the column to get the idea. K is the constant. That means when everybody is changing, K will remain as a half for this question. Always remain a half for this question. So let us continue working. So you have to go back to the same formula that says Y is equal to KX. Y is equal to K. Y is 9. Let us substitute. 9 is equal to K, which is a half, times X. And X is a T value that I don't know. Right here. So in solving for this, I need to find T. So I'm going to multiply both sides by 2. So that on my left side, 2 cancel itself. So 18 is equal to T. Or you could say T is equal to 18. So there it is that we have that. Let us now take a look at the other problem. The other problem is right here. The intention is that we want to find U. U is actually a Y value that we don't know yet. We do know, though, that we have the X value for it because if you look in the column, X is equal to 10 at that point. Also, K is the constant of variation, which means that when everything else is changing, K remains at 2.5 in this case. Now, the same formula that we have been using will work until this question is finished. Y is equal to KX. Now, as you could see, Y is what we want to find. It is called U, and it is equal to K, which is half, times X, and X in this case is 10. Finally, if you break this down, you would see that U is equal to 5. So there it is. So we have just found that. So the answer is T is equal to 18 and U is equal to 5. And there it is. Variation does come yearly. I've seen it so often. All right, another factorization question pops up. A lot of factorization come every year. This one is the difference of 2 squared. As you could see, the moment I have the difference of 2 squared and there is nothing in common for the two terms, I'm just going to take the square root. So the square root of X is X. The square root of 36 is 6. And you repeat the same thing. You put a plus, you put a minus. Normally, this is just 1 mark. So this is a 1 mark question most times. But sometimes they give 2. As you could see, this is for 2 this time. All right, let's go. For this other question here, we're looking at factorizing 2x squared plus 5x minus 12. Whenever I'm factorizing, I would always say to us, listen, take a look if there is anything that is common for all your terms first. That's your first move. So there's nothing in common, which means that I'm going to have to identify my A, which is 2, my B, which is 5, and my C, which is negative 12. I want to take note, when I see the negatives, I highlight it. Show respect for your negative. Because if you really miss that negative, you're going to spoil everything. So what we're going to do is to just find our AC. AC means A times C. So that is 2 times negative 12, and we're getting negative 24. Let us list all the factor pairs of 24. So the factor pairs of 24 are as follows. 24 times 1, 12 times 2, 8 times 3, 6 times 4. So these are all the possible numbers that can multiply to give you 24 in this pair in this way. So we want one of these pairs such that when you add them, you will get 5. But when you multiply them, you get your negative 24. So if you're thinking of 3 and 8. So we want to isolate our 3 and our 8. These two numbers should be able to work the trick, but we have to remember where to put our signs. Remember, if AC is negative, one of these numbers will be negative and one will be positive. The deal is that let us focus on our B value. The B value is a positive 5. So normally, if we want to know what to do when one will be negative and one will be positive, let the bigger number take any sign B has. Let the bigger one take any sign B has. B is positive. So that means 8 is going to be positive. The 3 will be negative. Now, let us double check to see if this makes sense. So positive 8 times negative 3 will give me negative 24. This is my AC. Positive 8 plus negative 3 will give me positive 5. This is my B value. So there it is that we satisfy that. When you satisfy this, you're going to take these two values and we're going to insert them in the middle. So basically, we could write back the first and the last term. Positive 8. Remember to attach the variable for the middle, which is x. And negative 3, x. So now we have 4 terms. If I have 4 terms and I'm factorizing, then I'm going to use grouping. So this is my group 1, and this is my group 2. So what are we going to do here? Let's factorize the first group. What is common for 2x squared plus 8x? Well, that is 2x. Let's open our bracket. We're going to divide 2x into 2x squared. We're going to left with x. We're going to divide 2x into 8x. We're going to be left with 4. So now we have this part. Let's focus on my group 2. What is common for negative 3x, negative 12? It's going to be negative 3. Opening my bracket. Negative 3 into negative 3x, I'm left with positive x. And negative 3 into negative 12, I'm left with positive 4. I'll say again, each time I reach here, I will stop to look. And I'm looking to see if my bracket is identical. The moment I realize it's identical, it means that I'm at the end of the road. It is my common factor, x plus 4. So let us write back our common factor, x plus 4. If we divide x plus 4 into these things here, you're going to get 2x in one and negative 3 in the other. Or what we could say is like, as soon as I find my common factor, the two things that are left on the outside, basically, you plug them in the other bracket. That's what basically happened. So there it is. We would factorize one more time. Let us take note of these ideas because these are really the stuff that comes each time. All right, let's keep going. So we're looking at, given that f of x is equal to 4x minus 7, and g of x is equal to 3x plus 4 over 2, we want to determine the values of g of 0 plus g of 5. A lot of times I've seen where people would have seen this and they walk away from it. But basically what you want to do is to find them both, and then you're going to add them. Just do what the math asks you to do. You're supposed to be adding them. But let us find them first. So this is my g function, and it says that g of x is equal to 3x plus 1 over 2. If I'm going to find g of 0, what it means is that 0 will take the place of x. So instead of having 3 times x, I'm going to have 3 times 0 plus 1 over 2. Let me highlight it for us. This is the only thing that we're doing. We're placing the x, the 0 where the x is. So 3 times 0 becomes 0. So we're really left with 1 over 2. So g of 0 is actually a half. Now let us find g of 5. So we're going for g of 5. So g of 5 would have meant that we're going to put 5 where the x is, plus 1 over 2. So in g of 5, I'm using the g function, but I'm putting 5 where the x is. 3, 5, 15 plus 1 over 2. So this is 16 over 2, which is 8. So g of 5 is actually 8. So when we're asked to find the value of g of 0 plus g of 5, basically what we're doing is saying a half plus 8, and that is equal to 8.5. Or you might say 17/2. Whichever way you want to put it, it's good to go. So what I'm saying here, you evaluate your function just the same. And if you're asked to do things, you do it. Now, in this question here, we're doing a composite function. So in the composite function, we're asked to do f of g of 5. Now, luckily, I would have found g of 5 already. Let's take a look. G of 5 in the same problem was actually 8. So instead of doing this over, I'm not going to do it over because I have a value for g of 5 already. G of 5 is 8. Now let's go for the f function. It says f of x is equal to 4x minus 7. So let me write it. F of x is equal to 4x with a minus 7. So let's take a look on it one more time. 4x minus 7. That is correct. So what we're required to do is f of g of 5. Now, what does this really mean? It means that we need to find the value for g of 5. And whatever value I have for g of 5, I'm going to insert it in the f function. Technically, what I'm finding right now, because g of 5 is 8, it is like I'm finding f of 8, because g of 5 is 8, and g of 5 is in the f function. So what I'm going to really do is just to substitute 8 in the f function. So 4x would become 4, 8, and then minus 7. 4 eighths, that's 32, minus the 7, and I believe that this is 25. So conclusion is that f of g of 5 is equal to 25. And we would have answered the question that they asked right here. There it is. All right. So let's write this one down. So it says f of x is equal to 4x with a minus 7. I normally double check a lot of times if I'm moving up and down the screen. There it is. We're good. All right. So at this question here, what we're doing is that we want to find the inverse of f of 1. But if I'm going to find the inverse of f of 1, why not just find the inverse of f of x? So I'm going to find the inverse of f of x, and then I'm going to put 1 in it. So let's go for the inverse of f of x. I'll just say this to you. I'm going to let f of x equal y such that y is equal to 4x minus 7. That's all. So this statement is just for what I'm about to do. So when we're doing the inverse, we switch x and y. We switch. So the y becomes x and the x becomes y. So that's step 1, you switch. Step 2, you transpose for the new y. So we're going to try to isolate this. So in order to isolate that, what we want to do is to not to stress ourselves too much. Let's add 7 to both sides. So what we do have is x plus 7 equal to 4y. Remember, the aim is that we want to have y by itself. So we're going to divide both sides by 4. So now we're seeing it where y is by itself. So I could just write this that, hey, y is equal to x plus 7 all over 4. which means that the inverse of f of x is x plus 7 over 4. But the question asks us for, why not put a 1 in this? So we're going to put 1 there. So 1 plus 7 over 4. 1 plus 7 is 8 over 4, 2. Conclusion, the inverse of f of 1 is 2. There it is. So basically what I'm saying here, what I did was I simply just take my time, find the inverse of the function, and then I input the 1 in there because of what the question had asked. That's all. So sometimes you can take that approach. And there are a few ways to approach the problems. Sometimes I choose based on how I feel at the time. All right. All right, so let's go. All right, let's see what else we have coming. All right. Transposition is also a part of the whole thing that you get. So it says the formula for the volume of a cylinder is given as V is equal to pi r square h. So that's the volume of a cylinder. Make r the subject of the formula. All right, so what we have is V is equal to pi r square h. And the intention is to make r the subject. So you want to make sure that you highlight what you're doing. If I want to make r the subject, it means then I want to isolate the r. So the things that are surrounding r right now, you want to look to see what are the things that are surrounding r and how do I remove them. So what I have is pi r square h. So I'm going to divide both sides by pi h. So you could see that the pi cancel the pi here and the h cancel the h. But remember in math, whatever we do on one side, we have to do it to the other side. So I'm going to divide the other side by pi h. So let me write back what we really have. We have v over pi h, and this is equal to r squared. So v over pi h is equal to r squared. I don't want r squared, I want r. So it simply means then I'm going to have to take the square root. I'm going to have to take the square root of r squared because the square root is what cancels a square. And then I'm going to have to take the square root of the other side. And you notice I make sure that I cover everything. So the final response is that when you take the square root of r squared, the square root and the square cancel. So r is now left alone, which is equal to the square root of v over pi h, right? And if you notice, I make sure that everything has surrounded this. Just be careful, right? You don't want to leave any part out. You want to make sure that you show that the square root covers everything. And that is the answer for that question, all right? Now let's take a look at this. So this one says, given that x squared plus, given that x squared plus ax plus b is equal to a plus x all squared minus 2. Work out the values of a and b. What I'm going to do to work out the values of a and b here is that I like to do what I have, work out what I have with the knowledge I have, and then I take a look on the situation. So let us take a look. I'm going to put, so I'm going to focus on the right side. Let me write this. So we have x squared plus ax plus b, right? And this is equal to x plus 2 squared minus 3. I'm going to focus on the right side. So allow me to break this up. And then we're going to keep carrying this all the way down each time to compare. That's all. So let us work out x plus 2 squared. I'm going to work it at this side, that part. What it really means is that x plus 2 times x plus 2. That's what it really means. There are multiple ways to get out this answer. I'm just going to approach it one way. You could multiply these two. So that is x squared. Then you multiply these. That is plus 2x. Then you multiply this, that is also 2x again. Then you multiply this, and that's positive 4. Finally, this is actually x squared plus 4x plus 4. Now, take a look. There is a subtract 3 here. So you minus the 3. So you're looking at x squared plus 4x plus 1. Because 4 minus 3 is 1. Let's bring this back here. So when I come back here, this is what I have. I actually have x squared plus 4x plus 1. Now you're going to take a look at the two sides, right? And you're going to equate what we call equating coefficients. So you could see that we're looking for a and b. So I'm going to highlight the common things that we're looking at. Look at this here and take a look at this. Let me change the marker for this as well. And take a look at this and take a look at that. So my color coding there would have helped us to see what's going on. So basically then, if you're saying ax is equal to 4x, yeah, then you could see, take off the x's, yeah, a is 4, done. And then now, x squared is x squared, so b is actually 1. So that is what we do. So the idea is that don't just look at a problem and then wondering what to do. I would suggest that you would do what you know. And I'm positive that a lot of us would have known what to do here. In other words, can I multiply something by itself? Yes, do it. Can I take 1 from it? Yes, you can. But you remember that you only can subtract terms that are alike. So the 4 minus the 3 is my only a shot there. I can't trouble 4x or x squared. And then you bring it back and then observe, take a look, all right? And then you solve a problem. So you equate coefficients there and you're good. Let's keep going. All right. Coming down, we have probably 2 questions. All right, so what we're looking at here is, as the table below shows pairs of values of x and y, where y is inversely proportional to x. Now, this is another variation, but this one now we're dealing with inverse proportional. So we have to take note. Now, I'm going to write the formula. It says express y in terms of x, all right, express y in terms of x and a constant k. So here it is that we're told what to use as our constant k. So we're looking at, so right now we're looking at the sentence where y varies inversely. So you got to start off by saying y is equal to, all right? So it's inversely proportional to x. So here's the thing, with inverse proportion, the constant of variation will always be on top of the last variable, right? So if you want to understand why, this is where it comes from. Y is equal to k times the inverse of the other one. So the inverse of x is 1 over x. That's where it comes from. Now, if you take a look at this, k is actually k over 1. So if you should basically simplify this, you'll get k on top of x. So that is why we are saying that to avoid all the working out here, just know that whenever you're doing the inverse proportion, the second variable will go as a denominator. It's going to go underneath the constant of variation. So this is what we need. All right? Just for 1 mark. Now let us keep going. Let's see what we have here. It says here, calculate the value of k. If I'm going to calculate the value of k, I'm going to focus on 2 things. Well, 1 thing. I want to focus on a column that I have the value for x and the value for y. And you can see that I could use this. And I think that they really love you this year because, look, they gave you 2 things to work with. So if you want to use 3 with 2, you can. Or if you want to use 4 with 1.5, you can. But I'm just saying, don't waste your time and do 2. You're going to get the same k. So I'm going to pick 3 and 2. So in order to find k, I'm going to say let x equal to 3 from that. And then when x was 3, y was actually 2. So I know that much, right? So that is what we got from them. Let's write back the formula that you have to use. Remember, the formula says that y is equal to k over x. And that is all. So let's keep going. Y is 2. So 2 is equal to k of which I don't know yet, over x, but x is 3. And there it is. So the only thing you want to do is to make sure that the numbers that you pick up there are right. So how do I find k from this? I'm going to find k here by simply multiply both sides by 3. So on my left side, 3 2's give me 6. On my right side, you can see that this would have canceled. So 1 times k is k. So the value of k is equal to 1. Now, when you know this value here, it is going to be the same value for k until this problem is finished. So the only things that will be changing will be the x values and the y values because they are variables. So they will be having various values. So let us see. They want us to determine the value of a and b. Now remember, I could actually write this that remember that k is 6. So let us go for one of the situations. So in this situation, I'm going to focus on A since it's right here. So I'm going to deal with A. So A is an X value, right? And the Y is 1.2. So X is an A value that we don't know. And the Y value when X is A is equal to 1.2. And you want to make sure you double check. So I'm looking back, X is A and Y is 1. So there it is that we have the values that we want. So what we're going to do here is that we're going to simply write back the formula that y is equal to k over x. Y is 1.2 is equal to k, which is 6 over x. X is an a value that we don't know. So what you want to do is to isolate the a value now. You could put the 1.2 over 1 if you want to work. So basically, what we're going to do, I'm going to do a quick cross multiplication. Take a look. So I'm going to multiply this with that, and then this with that, and then we just solve it. 1 times 6 is 6, which is equal to a times 1.2 is going to give me 1.2a. So I do a quick cross multiplication. So I'm going to divide by 1.2, divide both sides by 1.2, and that's going to tell me what it is, right? All right, so it's like about 50. All right, so 6 divided by 1.2, we'll get 5. So A is equal to 5. So there it is that we have an A value of 5, and we're done with one part. Now we're going to be doing the other part. So what we want to do is we want to go back to see what's going on for the B value. X is 20 when Y is B. So X is equal to 20. Y is equal to B. We don't know it yet. But K still remains to be that 6 for this question. So then Y is equal to K over X. Y is B. We want to find a B value here. K is 6. X is 20. So all we want to do is to break this down, right? So 6 divided by 20 will give me that B is equal to 0.3. And that's it. You're done. So A is equal to 5 and B is equal to 0.3. All right. All right, so let's take a look at this question. So this question says, the diagram below shows the graph of a function f of x is equal to x squared minus 6x plus 8 for values of x from 0 to 6. All right. Now, let's see what they want us to do. First question says, use a graph to solve the equation x squared minus 6x plus 8 equals 0. So they want you to solve where all of this function is equal to 0, right? So where it equal to 0, you could see 0 is here. So where a function is equal to 0 is actually the x-axis. In other words, then, the solution is the x-intercept. Where did the graph cross the x-axis? Take a look. All you have to do is to follow the graph. and you want to see where it crosses the x-axis. And wherever it crosses the x-axis, those are the solutions. Let's take a look. Definitely cross the axis right there and there. So the two solutions that we're looking for are as follows. One of them is where x is equal to 2, and the other one is where x is equal to 4. So those are my two solutions. We write them in. So x is equal to 2, x is equal to 4. There it is that we have those solutions very easily. So there are other terminologies that we can use to solve. They could say find the roots, the same thing they're looking for. They could say find the x-intercept. They could say solve, all right? So those are what you pick up quickly. Write down the coordinates of the minimum point in the form. So in other words, they're asking you to write a coordinate. X, Y, that's a coordinate. What's the minimum point? The minimum point would have been the lowest value that this graph would be able to take on. If I should do a quick simulation and talk you through it, you're going to hear when it reached the minimum. Listen, if I'm saying we start on the function, we're going down, 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 then we start going up. The fact that you were going down and you realize you're going up would have meant that you would have reached your lowest and turned. Let's go again. Down, 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 down. After this, we start going up. That means that we would have reached our lowest. So what is the lowest? The lowest is right at that apex right here. Let's pick up that apex. Let's highlight it. Our apex is right here. That is where, so that is what we call the turning point. So right here is that lowest point. So what I got to do is to pick up the x value and pick up the y value that meets right here. This y value here is not on the graph, but you should be able to read between the scales to know that this is -1 right here. So that means in terms of a coordinate, we have to name the x value first. So this is going to be 3, -1. So remember that you have to name your x value followed by the y value. So let me write it at the right place. Solution, 3, -1. So that is the minimum point of that function in green. All right, let's keep going. Now, so this that we have here, it says write x squared minus 6x plus 8 in the form a, open bracket, x plus h all squared plus k, where a, h, and k are constants. In other words, then they want you to complete the square. There are many ways to do this. I'm going to give you one way, right? So in order to complete the square, what we could do, we could use a formula, and we could do another approach. I'm just going to drop the formula here. So h is actually b over 2a. That means I'm going to find a value for h and I'm going to put it there. So b over 2a. What is my a? A is equal to 1, b is equal to -6, c is equal to 8. All right, so I'm going to use these. So b is going to equal to -6 over 2 times a is 1. So in other words, then -6 over 2, h is equal to -3. So there it is, I have my h. Now, the second thing that I'm going for is to find my k value, right? We can find k by still using a formula that says 4ac minus b squared over 4a. Truth to be told, you can find a few formulas. I could create more formulas out of this, right? So I'm not focusing on that right now. I'm just saying this could work. You plug it in and you're good. So 4 times a is 1 times c is 8 minus b squared -6 squared all over 4a. A is 1. Keep working. 4 times 1 times 8, that's 32, minus -6 squared is 36 over 4. I'm almost there. This gives me -4 over 4. K is equal to -1. So there it is, my k value is -1. Now I'm going to just put this in the format 1, because this is the format a outside, and then x is always there. H is -3. The square is always there. And I found the K value to be -1. Normally, because this is a 1 here, and it's multiplying by the idea, most times we just do this. But it's okay if you have that, or if you have this right now, you're good to go. So in other words, then, I'm saying that to complete the square, there are many ways to approach it. However, all right, however, what we can do is simply just use the formula to get it. All right. All right, there it is. All right, so the follow-up question is that they want us to, on the axis with the graph, they want us to draw this g of, okay, so they want us to put g of x is equal to x minus 2. All right, so on this graph, they want us to put on it g of x is equal to x minus 2. So you want to put it on it. So they said g of x is equal to x minus 2. So, I mean, there are many ways you can do it. What I'll suggest to some people is that, hey, use the numbers on your x-axis to substitute. For example, you could draw up a table and you could say this is x and this is y. All you need is 2 coordinates, 2 points. You create them, right? So you could say it for yourself. You could say, all right, if x is 1, like you are creating it, you could say if x is 1, and then you substitute 1 in the formula. For example, g of x is equal to 1 minus 2. You are saying let x be 1, and this is going to give you a -1, so -1. So in other words, then, this is suggesting that a point is 1 with a -1. This is your x that you suggest, and it spits out a y value, input, output. Let's do another value. G of x is equal to any value that you want to choose. Let us say I choose 3. Then I'm going to put 3 where the x is. So instead of saying x minus 2, I'm going to say 3, then a minus 2. That becomes +1, which means that I just tried 3 and I got 1, right? So in other words, then 3, 1 is another coordinate. So you could plot these 2 points. What 2 points I'm referring to? I'm referring to plotting this and plotting this, right? So let's plot them. 1, -1 is right here. And 3, +1 is right here. All right. And we're good. Right. Let us just draw that line right about now. Let me draw the line for you. All right, there it is. All right, so there it is right there. Let me put it in blue. All right, so there it is. So that's the line that we just drew, which is, this is the line that says g of x is equal to x minus 2. The original one that we had was that this one that we have here, this one is f of, I think it is f of x is equal to x squared minus 6x plus 8. All right, so that's what that one is, and that's the other one. So that is what they asked us to do, right? Put it on. So we put it on, we grab 2 points, and there's another way that we could do this, but in the interest of time, I'll just leave it. You could just use your slope and the y-intercept to create the line, right? But that's for another time. All right, so that's that. Let us see what's the other question. So we just did this. We put on this on the grid. Let's see the other question. Oh, so the last question, it says hence, which means based on what you just did, solve this, where x squared minus 6x plus 8 is equal to x minus 2. This was the f function that we had, and this was the g function that we just put on. We want to find where they equal. So that is what the solution of this is to see where they intersect, where they cross path. So if you look, you would notice that they did cross each other here and here, right? That's where they cross each other. So what you want to do is to have those solutions, and there's two pair. So here, x was 5 and y was 2, meaning right here, see, 5, 2, that is solution 1. And here is 2, 0. That's the other solution. So the two solutions are as follows. 2, 0 is one, and 5, 2 is the other solution. Remember, the idea is that the solution is where they cross each other. Because if you have two graphs in one axis, meaning on one graph paper right there, on the same axis, or they phrase it, where they cross path, that's where they're equal to each other. That is their solution. So if you're able to read off their coordinates, then you would have gotten their answer there. And that is 2, 0, and 5, 2. Remember, x, then y, x, then y. All right, so that is phase 1 of the revision series that I'm coming up with. I trust that this would have made some sense to you and that you would have seen some ideas that you actually appreciate. Remember, like the channel, subscribe, and always check DellyMaths concepts because we have stuff coming out every time. See you next time.